Section 4.2 talks about, is on page 258, talks about the natural exponential function, and all what the natural exponential function is an exponential, just like we had in the previous section. If a is bigger than 0 not equal to 1, well here it's fixed. Here exponential function f of x equal c times e raised to the x, where e to the 1 is actually it is a number that never repeats, never terminates. It's like pi. Alright? So what we need, 2.7 is sufficient for us to really look at this, which means if I'm looking at a graph of y equal e to the x, well, since the base is bigger than 1 from the previous section, I know that's exponential growth. And if I look at the graph of y equal e to the negative x, you might say we multiplied the power by a negative, multiplied the x to reflect the graph with respect to the y-axis, or you could say, you know what, that's e to the negative 1 to the x, that is 1 over e to the x, and 1 over 2.7 is less than 1, that's exponential decay. So a couple of quick problems I want to tackle and then go to the applications and talk about those. On page 264 we want to look at few problems. Number 2 is a refresher. Remember, if you're dealing with a negative power, you could reflect, take the reciprocal of that and change the power from positive to negative, and that's e squared. I'm breaking my rule. Instead of working downwards, I'm going to work to the right. Here, if I want to get rid of that negative power, I could take the reciprocal of that fraction. I could say that's e to the second divided by e to the fifth. And if you remember, exponentials, the denominator has a higher power, so I'm going to subtract those. 5 minus 2 is 3. Here, if you multiply exponentials, you add the powers, that's e to the 8. And any number other than 0 raised to the 0 power is 1. You can't leave your answer with a negative power. You move things up or down by changing the power from positive to negative. As far as graphing, we want to pick a couple of points. And the best way to do that, figure out where that power equals 0, a point above it and a point below it. We know exponentials how they look like already. You could say this is e to the second power to the x. Since the base is bigger than 1, that's exponential growth, and just give me that graph. The line doesn't change, and that point is 0, 1, everybody's happy. Or plug 0 in, you get 1. Throw 1 in. Remember, e is 2.71. 2.7 raised to the second power is a positive number, bigger than 1 for sure. And if you put a negative 1, you get e to the negative 2, which is 1 over e to the second. 1 over 4 is about 0.25. If I want to graph this, if you know about shifting, you could use that. If not, where does the power equal 0? The power equals 0 at negative 2. A point above that and a point below that will do the trick. Negative 2 in there, e to the 0 is 1. So negative 1, negative 2, 1. There's that initial point that I need. If I put a negative 1 in there, I get negative 1 plus 2 e to the 1. At negative 1, I am at 1, 2.7, about right there. If I put negative 3 plus 2 is negative 1. E to the negative 1 is 1 over e. So that's 1 over 2.7, which is about a half. Fit that in a smooth curve. There's my graph. Label that asymptote clearly, and that point should be clearly labeled. And that's the first batch of problems. Now we want to talk about applications, and let's get that out of the way. Alright, now a equals p into 1 plus r over n raised to the nt. This is compounded interest n times per year. Where, if I look at those variables, p is the principal. Since we're going to talk about money in this case, this is the deposit. It's really the starting point, the start. How much do you put into the bank? R is the interest rate. And that is always in decimal. T is the number of years. A is the amount after some time have passed. Or you could say this is the balance. And n is the tricky part. N is the number of compounds per year. That is, if they say yearly, well, how many years are there in a year? There's one. If they say semi-yearly or semi-annually, then you break the year into two. If they say quarterly, then you break the year into quarters. There's 4 of them. If they say monthly, you break the year into monthly. How many months are there in a year? 12. And if they say daily, how many days are in the year? We're going to assume 365. That's one formula. There is another formula. So let me separate really quick. There is another formula, and that formula works for compounded continuous or continuous compound. A equals P into e to the RT. And everything is identical to the top except there's no n. If you do continuous compound, after we do limits, I'm going to come back and elaborate on this a bit. So I have 2 formulas to play with, and I want to play with those on the following problems. And here we're going to continue, fill up this table. So I have A equal P into 1 plus R over n to the nt. And I have A equal P times e to the RT. This is n times per year. And this is continuous. So when they say complete the table to determine the balance of A, they're saying look for A. When $3,000 is invested, well, we know for all of these problems, P is $3,000. Rate, this is R. R is 0.025, and T is 20. We got them. Very good. So we want to fill this table. It's a matter of using a calculator. Make sure you get a scientific calculator, and we're going to play with that. When they say in the first part n equal 1, when they say n equal 1, this is called simple interest, by the way. A equals P into 1 plus R over n raised to the nt. So A is what I'm looking for. 3,000 is the deposit, parentheses 1 plus 0.025 divided by n, in this case is 1 raised to the 1 times 20. And I could, in my calculator, and you need a scientific calculator so you could do what I'm going to do. You write it as you see it. 3,000, parentheses, 1 plus 0.025 divided by 1, raised to the 1 times 20. And I get $4,915.85. I'll get $4,915.85. You always round to 2 decimals when you're dealing with money. And that takes care of this problem. If I look at the second, so this should go in there, but I can't fit him there. If we go for n equal 2, do you notice that nothing changes except that yellow part? So doesn't a equal 3,000? Same, 1 plus 0.025. Wouldn't the only thing that will change, instead of that being 1, now n equal 2, that means semi? If I go to my calculator, there's no need for me to reinvent the wheel. All what I have to do is go back. There's a back button. Some calculators you pick the upper. It takes you back. And all what you have to do is change that right there, delete it, and input a 2 instead. Delete that and put a 2 instead. And there it is, if you look at the equation. Now, if I was to get my interest twice a year, then I would really get 4,000. I'll get $4,930.86. That's the answer. And as you see, I really don't have to do much. When I go to, so this is yearly, this is semi, this is quarterly, this is monthly, and this is daily. They use those back and forth, and this is continuous. So when I go to n equal 4, do you see that I'm not going to write the formula now? I'm just going to go to the actual application and say, hey, look, go back and put a 4 right there and a 4 right there. Delete, put a 4 right there. Delete, put a 4 right there. Equal, there it is. Right? So A will equal 3,000. 1 plus 0.025 over 4 raised to the 4 times 20. And the amount would be an actual $4,938. And how many cents? 47 cents. And when I go to monthly, n equal 12, again, A will equal, now I'm just going to go back and put a 12 there, and go back and put a 12 there. Make sure you know how to use your calculator. That's $4,943, $4,943.59. And if I go for daily, I'm going to replace that by 365, right? So if I go for daily, I will go back and replace that by 365. $4,940 $4,946 and 8 pennies. And do you notice that the amount is not changing much as you start moving? Now, how about continuous? Continuous, A equal 3,000. So continuous, A equal P e to the RT. The formula is shorter. R is 0.025, right? Times 20. Well, A would equal what? If I go to my calculator, I'll notice now I have to change things. 3,000 parentheses, or actually 3,000, my calculator multiplies automatically. Yours, you could say multiply, and E is right there under natural log. And if I take 0.025 and multiply that by 20, I think I need parentheses there, but I'll double check. No, I don't. It'll be $4,946, $4,946.16. And do you see that that's almost identical to that amount? You're only off by 8 cents. So, first batch of problems, you want to practice how to input things in your calculator and make sure that you could use your scientific calculator properly. Okay, they'll change a few things here. Here they're saying, complete the table, determine the amount of money P that should be invested at a rate to find a balance A. So A equals P into 1 plus R over N raised to the NT. But they're giving us A in this case, and they're moving toward us figuring out what T is. So here, R is, so A is 100,000 equals P, which is what I'm looking for, into 1 plus compounded daily. Interest rate is 0.06 divided by 365, we agreed, times 365, and the varying part is T. Here they say if T equal 1, well, all what you have to do is figure out what this quantity is and divide both sides by it. And that's how it works. So if I get my calculator out and I take 1 plus 0.06 divided by 365 raised to the 365 equal, now that's starting my answer. So all what I have to do is say P equal 100,000 divided by my answer, which would be, and if I take 100,000 divided by answer, that gives me 94,176. 94,176 and 92 cents. If I deposit that much in a bank paying 6% interest compounded daily, at the end of the year I'll get 100,000. And what if they altered that? What if they said, well, what if we were to make that, let's pick another one, let's say 30 years. Well, 100,000 will equal P into 1 plus 0.06 divided by 365 raised to the 365, and what will change in this case, we could put 30 in there. And the same deal, if I take my calculator out and I figure out what is, now I could go back twice, I could go back twice and mimic that right there. It's right there. If you hit back arrow twice and right there say times 30, that'll take care of it, or input the whole thing. That's the amount. That's stored in my answer. So now I have 100,000. You could copy that down, or you could say, well, wait, that's stored in my answer. So P will be, and if I throw this in my calculator, what is 100,000 divided by that answer? That turns out to be 16,532. 16,532, and always pennies because it's money, 33 cents. If I deposit today in the bank 16,532 compounded continuously at 6% interest rate, I will accumulate at the end of 30 years 100,000. And here they say, what if it's continuous? Well, continuous use a different formula, that's it. So 100,000 equals P e to the r 0.06 times, and let's go for the first one again, put a 1 in there. Well, this is a bit simpler. I could say P equal 100,000 divided by e to the 0.06, or I could use the same analogy. I could say, you know what, I'm going to figure out what e raised to that 0.06 is, store that in my answer, and I'm going to take 100,000 divided by that. And there it is, 94176, 94176.45. It doesn't turn out to be much of a difference from what we got right here, because it's continuous and daily are very close. And if I do the 30 as well, I would say 100,000 equals P e to the 0.06 times, and here I'll put 30. Again, I could put any of these numbers. I could do the same game. I could go in there and say, let's go back twice. There it is. And I could go back and input in there times 30, and there it is. I could store that in my answer, right? And I could say, we'll take 100,000 divided by my answer. Or I could say 100,000 if I'm using the calculator, and I am. And I'll do both for you. And if I say 100 divided by my answer, I'll get 16,529, 16,529, and 89 cents. Now I could have done the whole thing one shot. 100 divided by parentheses. Oops. Forgive me. 100, wrong key. E, oops, divided by, and I could say, let's take e raised to the, what did we say, 0.06 times 30. That'll do the trick. There it is, same number, doesn't matter. So either way, that will work. The next problem up is number 34. I'm not sure if I gave you a page. Did I give you a page? Yeah, 64. Okay. The next problem up is number 34, and they're changing things slightly here. Effective rate is a key component of this section. What it does, it compares the different compounds with simple interest. Basically, it's like a scale. So here you have a bank that says, oh, we're going to give you quarterly for this many years, and another bank says, well, no, let's wait. We will give you a bit less of an interest, but we will increase and give you daily. So if you want to compare all of these together, it is a way to compare different compounds. And the effective rate formula is provided on your test. It's given by 1 plus r over n, quantity raised to the n minus 1. So this is a way for us to compare the different compounds from different banks. They give you different compounds. You compare them to each other by using the effect. Kind of like saying, okay, you know what? You have 3 different compounds. Let me see what all of these would mean if I was getting my interest once a year. And of course, you pick the biggest effect. So if I have number 38, it says effective rate. Find the effective rate of interest compound to a nominal rate of 7.5%. If a bank offers you 7.5% interest, if they're giving you the year annually, well, that's not much to do, but we're going to work it out anyways. N is, the interest is 0.75, and you do know what's going to change in this, right? When you say annually, well, doesn't that mean that you're going to really go for 1 there and 1 there? And the effective rate in this case will be, and I just have to input this once in my calculator. 1 plus 0.075 divided by 1 raised to the 1. And that turns out to be 1.075. 1.075. So that means it really didn't change much, because the 1 is the 1 year return. You get what you put in, plus the 0.75%. No need to worry about that yet until I tackle some problems later on, and we'll hammer this down. What if somebody says, I'm going to give you semi? You need to know, what does that mean? Am I getting double my money? Well, the effective rate would be 1 plus 0.075 divided by, and what's going to change? Semi means I'm going to put there a 2 instead. So I already did this. I go back, delete, put a 2 there, delete, put a 2 there. And that turns out to be 1.076. So that's the equivalent of 7. Oh, you know what? I forgot there's a -1. No wonder it's not matching. Okay, very good. I forgot the -1 right there. Kept on saying, we didn't talk about this yet. This comes up the 1. So do you see? If you get your interest yearly, well, that's actually the interest. That's simple interest. Compared to that, if a bank tells you we're going to give you semi-annually, they're really giving you, instead of 0.05, 7.5%, they're really giving you 7.6%. That's all that means. What if a bank says we're going to give you your money quarterly? Well, you want to know, what does that mean compared to the rest? That means you're really going to get your interest quarterly. Isn't that a 4? And again, if I just go back and put a 4 there, and oh, and now that I forgot about -1, right there, 0.077. So this bank is giving you roughly about 7.7% instead of 7.5%. So if you put $100, you'll get $7.50 right there. I'm sorry, if you put $100, you'll get, $7.50. Here you get $7.60. Here you get $7.70. And if you put it monthly, that's the equivalent of this bank paying me monthly, I'm sorry. There are 12 months in a year. And that would be 0.7, if you round, 8. So this bank is giving you roughly 7.8%. So in $100, here I'll get $7.50, $7.60, $7.70, and $7.80. 10 cents difference, that's it. And I want to tackle one more problem. I'll elaborate on that when we do the homework and enforce that. How about here? Present value. How much present should be deposited? That's P. They're asking for P. In an account paying 7% interest, 7.8%, 0.078. Investment compounded monthly and equal 12. In order to have a balance, I want A to be 21,000. Right? And the time is 4 years. So if I write my formula down, A equals P into 1 plus R over N raised to the NT. Well, this is 21,000 equals P into 1 plus R is 0.78 divided by 12 raised to the 12 times 4. Now, how am I going to do this? I'm going to use my calculator wisely. This is what I'm going to do. I'm going to work this out and say, you know what, 21,000 equal P. I'm going to throw this in my calculator. see what that is. But I'm not going to write it down because I don't want to wrong. Parentheses, 1 plus 0.078 divided by 12 raised to the 12 times 4. Got it. That's it right there, 1.3. I could write all of that down, or, do you see that answer key down there? That answer key is the last calculation that we just did. So, any calculator that you do a work, anytime you figure out a calculation, it stores it in the answer. And if 21,000 equal P times answer, what does P equal? Isn't P 21,000 divided by that answer? Since I'm using a calculator and I'm allowed to use it, might as well. So wouldn't it be best for me to just take 21,000 divided, and again, in the answer is stored the last calculation, and that will be 15,387. 15,387.14. If I was to deposit today $15,387 at an interest rate of 7.8% in 4 years, compounded monthly, I will get out of it. 4 years from now, I'll collect $21,000. Let me give you there's the homework on 4.2.